We've spent a lot of time in our recent deep dives on the individual building blocks of the cloud. We've looked at
Mm,
compute, storage, regions, security
for
controls,
raw material.
exactly the raw materials. We know how to order them, how to set up the foundation.
Yeah.
But here's the massive critical question that really determines success or failure.
hmm
Can we actually build a good, reliable, and sustainable system out of all those parts?
That is the ultimate test, isn't it? I mean, it's the difference between having a pile of excellent components and actually engineering a robust high-performance machine.
Right.
The sheer scale of modern cloud workloads means you can't just, stitch services together and hope for the best. You need a governing philosophy.
And that philosophy, for anyone building on AWS, really comes down to the well-architected framework.
Yeah.
So we're dedicating this deep dive to understanding its architecture, how to put those pieces together in the absolute best way possible.
Exactly. Our mission today is to move beyond just the service catalog and really focus on quality control. We're going to unpack the 6 core principles that define excellence in cloud design.
Okay.
We'll look at the specialized services that can accelerate innovation and then connect this whole framework back to tangible business outcomes for you. It's all about creating systems that are resilient, efficient, and cost-aware from day one.
Okay, let's unpack this. So
After
let's
that.
start with the framework itself. We've said it's a standard, not a service you buy. It's more like a set of detailed white papers, a guidebook.
That's right.
Why do we even need this guidebook?
Yeah.
Isn't robust architecture just intuitive?
It's intuitive until you hit scale. The goal of cloud architecture isn't just getting an application to run. It's about building a system that is secure, high-performing, resilient, and efficient all at the same time.
Right, across all those different dimensions.
And the framework exists because the complexity of making trade-offs between those dimensions is enormous.
Trade-offs, okay, unpack that for me. What kind of trade-offs are we talking about?
Well, every single design decision involves them. I mean, think about it. If you implement maximum security, say, constantly encrypting and decrypting data, that might introduce latency, which hurts your performance.
I see.
Or if you build a system that can recover from any possible failure instantly, the ultimate in reliability, that's going to be really expensive. And that hammers your cost optimization pillar.
So the framework isn't just a list of good things to do. It's more of a structured way to manage the inherent tension between these competing goals.
Precisely. It gives you those 6 key concepts, the pillars, to help you ask the tough questions before you deploy anything. It's basically a comprehensive checklist for identifying risk.
And it's a practical tool, not just theory.
Oh, absolutely. It's not academic at all. AWS provides the well-architected tool right in the management console. You can use it to systematically review your workloads against these standards and flag high-risk items immediately.
That brings us to the core of it then. We need to define those 6 foundational concepts, the pillars. So let's walk through them, starting with the day-to-day operations.
The first pillar is operational excellence. This is all about the commitment to continually improving your processes, running systems smoothly, and monitoring them effectively.
Okay, so when I hear that, I think good documentation. But that seems a little too simple, isn't it? Is that just common sense?
Well, that's where the cloud changes the definition. Common sense documentation is a static manual you put on a shelf. Operational excellence is dynamic. It's about performing operations as code.
As code.
Yeah, using infrastructure services like CloudFormation to automate your deployments and your management entirely. And critically, it means defining success with metrics, not just is the system up, but
What's our deployment failure rate? Or how fast can we roll back?
exactly. You need clear, measurable governance over your processes.
That's a great distinction. Okay. Automation, metrics, process. Got it. Pillar number 2 is security. We know this is about protecting information and assets, but what's the advanced take here?
The focus is really on implementing security at every single layer, not just at the perimeter. Of course, you follow the principle of least privilege. No one gets more access than they absolutely need.
Sure, that's fundamental.
But the real depth comes from treating security as a continuous, automated process. You're automating vulnerability detection, using services to automatically detect and respond to threats, and logging everything so you can prove compliance and trace any incident instantly.
Okay, so if OpEx is about process, what happens when a process or a component fails? That leads us straight into reliability, I assume.
It does. Reliability is all about ensuring your workload performs its function consistently and, crucially, that you can recover from failure quickly.
This is where we see the most explicit investment, usually.
For sure. We're talking about implementing automated recovery. So when one server fails, another just takes its place instantly. You use services like auto-scaling and elastic load balancing, ELB, to achieve horizontal scaling.
So the system is designed not just to withstand failure, but to self-heal.
Exactly, without any human intervention.
Now, a natural comparison to reliability is the next pillar. Performance efficiency. What's the subtle difference there? Because they sound similar.
Yeah, they do, but they're distinct. Reliability is about staying up and recovering. Performance efficiency is about using your resources effectively to be fast and responsive.
So a reliable system could still be slow.
Precisely. A performance-efficient system is optimized. This pillar is all about selecting the right instance type for your exact workload. Don't pay for 16 CPUs if you only need 4, and making sure your scaling is based on real-time metrics, not guesswork. You're always matching supply precisely to demand.
And matching supply to demand is the perfect lead-in for Killer 5. Cost optimization. How do we talk to the people paying the bills?
By focusing relentlessly on avoiding unnecessary costs. Practically, this means aggressively right-sizing your resources, using tools to find and automatically delete unused things like old storage volumes or forgotten snapshots.
And using commitments.
Yes, using long-term commitments like reserved instances or savings plans for your predictable workloads to get big price breaks. Cost isn't just about buying cheap, it's about buying smart and deleting waste.
And finally, rounding out the framework is the newest pillar, which I think reflects a global shift in how we measure success. Sustainability.
It does, and sustainability focuses on minimizing the environmental impact of your workloads. What's great is that this often aligns perfectly with cost optimization.
How so?
Well, it means maximizing resource utilization. The more efficiently your code runs, the less energy is wasted. It also heavily favors energy-efficient services like serverless models like Lambda, because AWS is managing the underlying hardware efficiency at a massive scale.
That is a fantastic breakdown. Let's go back to that tension point you mentioned earlier. You said reliability and cost optimization are often in conflict. Can you give us a real-world example of that?
Certainly. Let's take a non-critical internal tool, maybe an inventory dashboard that's only used once a day.
Okay.
For maximum reliability, we deploy that across 2 different geographic regions with automatic failover, fully provisioned standby capacity. That would be very, very expensive, probably overkill.
Right.
The trade-off is to reduce the reliability. Maybe you accept a manual failover process or even 30 minutes of downtime. In exchange, you get significantly better cost optimization. The framework just forces you to articulate that risk and make sure it's an intentional choice, not an accident.
That completely changes the conversation. It's not about asking, is this perfect? But is this the best balance of risks for my specific business goals?
Precisely. The perfect system doesn't exist, only the optimal system for your requirements.
Okay, let's shift gears a bit. Let's move beyond the core components like EC2 and S3 and talk about the huge library of specialized services. You said there are over 200 of them.
Mm-hmm. And these specialized services are where the paradigm shift really happens. They democratize advanced technology by handling all the immense infrastructure complexity for you.
Letting you get from problem to solution much faster.
It's exactly, in weeks instead of years.
Let's dive into a few key areas where this is most obvious. Let's start with what is probably the most complex domain, machine learning and AI.
Right. Historically, if you wanted to run a custom ML model, you needed a massive team just to handle the hardware and the data pipelines. It was prohibitively expensive and slow.
So
Now we have Amazon SageMaker. It's a fully managed end-to-end platform. You just bring your data and your algorithm, and SageMaker handles all the complexity of building, training, and deploying those models at petabyte scale. It just removes months of infrastructure setup.
So it removes the infrastructure hurdle.
Yeah.
And what about for teams that don't need a custom model? They're ready to use services, right?
Absolutely. Think about natural language processing. Instead of building a model to understand sentiment in a million emails, you just use a ready-to-go API like Amazon Comprehend.
Wow.
Or if you need to analyze video for safety violations, you use Amazon Recognition. These are instant, advanced capabilities that don't require hiring a whole team of AI specialists.
Okay, another huge category is the Internet of Things, or IoT. The complexity there isn't just the data, it's the sheer number of connections.
Billions of them. Managing billions of connected sensors, manufacturing equipment, smart devices, that alone is an unmanageable security headache.
I can't even imagine.
Right. So AWS IoT Core solves that. It's a secure, managed service that lets all those devices connect to the cloud, handles their authentication, and ensures that massive influx of data flows reliably into your other services.
Okay, and the last category you want to touch on was data analytics. Most companies are drowning in data but starving for insights.
Thirsty for business intelligence, exactly. Services here are all about making it simple and cheap to query that raw data. Take Amazon Athena. It's a serverless querying service.
So no data warehouse to manage.
None. You just point Athena at your data stored cheaply in S3 and query it with standard SQL. You only pay for the queries you run.
And what about cleaning that data up first? The whole ETL process used to be a huge lift.
Correct. And that's where AWS Glue comes in. It's a serverless data integration service that makes it much easier to prepare and load your data for analytics. Again, it's all about removing the heavy lifting of managing servers so your team can focus on solving actual business problems.
Here's where it gets really interesting. How did these abstract pillars and specialized services actually translate into tangible business value? Let's go back to your example of disaster recovery.
Disaster recovery is the ultimate application of the reliability pillar, but you have to manage it with an eye on cost optimization. The old way, as we said, was maintaining an idle, expensive second data center.
Just sitting there burning money.
Exactly. The cloud flips this model. Instead of paying for idle servers, you use services like Amazon S3 cross-region replication to automatically copy your critical data to a separate region.
Okay, so the data is safe.
Right. Then you use infrastructure as code to spin up the necessary compute resources only when a disaster actually happens.
So you're paying pennies for data storage replication and only running the expensive application servers when you absolutely need them. That's a massive win for both reliability and cost.
It's transformative. It gives you a much better recovery time for a fraction of the cost. It satisfies two pillars at once.
I think the ultimate expression of combining all of this, the services, the framework, is the rise of the serverless architecture.
Oh, absolutely. It embodies what the framework aims for. Think about running an application using AWS Lambda for compute and DynamoDB for the database. There are no servers.
So right away, you've addressed operational excellence. You've essentially outsourced all that infrastructure management to AWS.
Exactly. And because Lambda scales instantly from 0 requests to 1,000,000 without any manual configuration, you have inherently solved performance efficiency. You never over-provision, but you always meet demand.
And the cost optimization is just built right in. You only pay for the exact millisecond your code is executing.
Right. When a system uses Lambda, DynamoDB, Athena, it's not just an application anymore. It's a solution that is optimized across the OpEx, performance, and cost pillars from the ground up. The framework is the roadmap, and these specialized services are the high-powered vehicles you use to get to your destination.
So that brings us to our summary. We've covered this really critical shift from thinking about individual services to thinking about quality architecture. The well-architected framework provides that essential guidance built on the foundation of the 6 pillars: operational excellence, security, reliability, performance efficiency, cost optimization, and of course, sustainability.
And we saw how specialized services like SageMaker, IoT Core, and Athena can just accelerate innovation in really complex areas by managing all that underlying infrastructure for you.
The overall goal remains fixed, though. Building systems that are secure, reliable, high-performing, and financially responsible. But the conversation you need to have internally is all about those trade-offs.
If we connect this to the bigger picture, understanding these 6 pillars allows you to intelligently participate in the most critical business discussions. You almost never get to optimize all 6 pillars at once. You have to decide where to spend your resources.
Right.
A slight reduction in, say, security rigor might allow for massive improvements in operational excellence, for example. You have to make those calls consciously.
Which means your new expertise isn't just knowing the definition of the pillars, but knowing how your specific business strategy prioritizes them. Understanding this framework means you can articulate not just what you need to build, but why a particular design choice, say, choosing a highly reliable, multi-region architecture over a cheaper option, is the best long-term strategy for your business. So we'll leave you with this question. What is the biggest trade-off, cost versus reliability, or perhaps security versus operational simplicity, that you will need to consciously prioritize and justify in your next system design? Thank you for joining us for the deep dive.